Good morning, boys and girls. Today for math, we are using subtraction strategies that we have learned to solve two-digit subtraction problems. I know that sounds a little bit redundant. So first, again, I want you to practice solving this problem in the try it area just to see what strategy you're using. I want you to go ahead, I want you to pause the video and I want you to practice. Now, you might be asking, Miss Rentschler, you can't see my work. Why do I need to try to do this? And you're right, I can't see your work, so I don't know if you're really pausing the video to stop and solve it or if you're not, but I do want to let you know that I strongly encourage you to still do the things that I ask you, even though I am not asking you to show me or to turn it in. So really what I'm doing is I'm trusting that you are doing this and that you are trying, because by you trying, you're on your own first and then coming back and looking and going over it, you're still able to learn. Maybe you're making a mistake and maybe you're learning something when you come back and you listen to me walk through it, and that's perfectly okay. That's what would happen in the classroom, because we don't always do things the same way, or maybe we are still learning, so mistakes happen, and even when we already know, mistakes still happen. So mistakes are perfectly fine, but I do want you to not just be like, oh, I'm just going to keep watching, I don't need to try. Because the more that we try and the more that we practice, the better we get. So it is still important that you are still trying, that you are still practicing, even if you think that you get this, okay? This week is a little bit of a review all over the place before we move on. I thought that would be a good idea, was to stop, pause, and review before we moved on to some other things. So yes, I'm asking you to pause, I'm asking you to try this on your own, and then we're moving on using your strategy, and I'm just having you look at it and compare it. But I still do hope that you are, I'm trusting that you are still doing the work, even if I'm not asking you to turn it in, because I would hate to have to ask you to turn everything in, because I know that takes a lot of time on you too. But I do hope that you are still doing the work. So, side note, the problem for today to get our brains working and warmed up: after school, 85 students go home. Some of the students go home on a bus, but 26 students do not go home on a bus. How many students go home on a bus? I feel like I just read go home on a bus 17 times. Anyways, I would like you to use any strategy that you have learned and that you like to solve this problem. All right. So again, you're using a strategy that you have learned so far and that you like to solve this problem. And I want you to use that strategy to compare it to these two. Okay? So you're flipping the page to look at this. This is the model it. This is the same problem up here. And the two strategies that the book is saying that you can do is to regroup a 10 first and then subtract. So let's look at why we have to regroup a 10 first, if my fingers would work. Let's say we set this problem up cookies and friends way. So we have 85 minus 26, right? And we line this up. Well, remember that this is the store, this is the cookies, and this is the friends. Do I have enough cookies to give one to all of my friends? I do not have enough cookies. I need 6 cookies, but I only have 5. I have to go to the store. I cannot just buy 1 cookie from the store. I have to buy an entire pack of 10. So the store had 8 packs of cookies on the shelf. I'm buying 1 pack. So that leaves 7 cookies on the shelf. I'm coming home. 1, 2, 3, 4, 5, 6, 7, 8. I'm coming home and I am unpacking that cookie, that pack of cookies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 cookies. But I already had 5. So 10, 11, 12, 13, 14, 15. I now have 15 cookies at home. Now, do I have enough cookies to give 1 to all of my friends? I sure do. 15 minus 6 is my new problem. So that is why they are saying to regroup a 10 first and then subtract. You can do it using base 10 blocks this way. So they're showing you 1, 2, 3, 4, 5, 6, 7, 8. But this 8th one is the one that we bought from the store. We're bringing it home and we're unpacking it. Then, let's see, 85 minus what equals 26. That's our problem. Then we're subtracting. So we have to subtract 6 ones. 1, 2, 3, 4, 5, 6. And 2 tens. 1, 2. So now we can count how many ones we have left and how many tens we have left. The other way that the book shows you that you can solve this problem is by using our favorite number line. Subtract 26 from 85 to find how many students go home on a bus. Start at 85, subtract 5 to the next 10. So remember, tens are those easy, nice, simple numbers to add and subtract with. So 85, to get to a 10, we have to subtract 5. Why on earth they subtracted 1 right there, I don't know. But they subtracted 1 to 79. And then they subtracted 20 to 59. Okay. So let's look at Connect It. We're going to need both of these pages for Connect It. And this is going to have to get taller again. Okay. So the Connect It page always looks at the Model It page. Look at the first Model It. What is 7 tens and 15 ones minus 2 tens and 6 ones? So if you're looking here, there's 1, 2, 3, 4, 5, 6, 7. 7 tens and 15 ones. Take away those 2 tens and those 6 ones. So how many tens do we have left? 1, 2, 3, 4, 5. There's 5 tens and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. So 7 tens and 15 ones minus 2 tens and 6 ones should be 59. Look at the second Model It. What number did you land on? What number did they land on their number line? 59, right? Why are the answers the same for problems 1 and 2? We're solving the same problem. We're solving the same problem, so the answer should be the same. Just because we use 2 different strategies does not mean that the answer is different. That is how we know well, that's one of the ways that we know that we did the strategy right, is that we ended up on the right number or the same number. If you can do 2 different strategies, end up on the same number, you should probably be right. I'm sure there's a 1% chance that somewhere, somehow, it's not the right answer, but you should be right. So we are solving the same math problem in, I'm going to abbreviate number with a pound sign. You might call it a hashtag. It's a pound sign. It actually has another sign too, name. Number 1 and number 2. Anyway. Explain how you can use addition to make sure your solution for 85 minus something equals 26 is correct. So what math problem could you use? Or how could you use an addition problem? So if you did 26 plus 59, you should equal 85, right? Because we're back to this again. 85, 26, 59. These two numbers added together should equal this number up here. Part, whole. We're not doing reflect. Okay. We're going to apply it, and then you are going to practice. Oh my gosh. My fingers are not working. Alright. Apply what you just learned to solve these problems. There are 65 cherries in a bowl. Dan eats 12 cherries with his lunch. How many cherries are in the bowl now? Use two different strategies to solve this problem and show your work. So I'm just going to draw a line down the middle. I'm going to do strategy number 1 over here. Strategy number 2 over here. Go ahead, pause the video, and try to solve this problem. Alright. So for my solution number 1, I'm going to set this up cookies and friends kind of style, or traditional subtraction. So I'm going to go 65 minus 12. So 5 minus 2, do I have enough cookies to give one to each of my friends? Yes, so I don't need to go to the store. I have 5, I take 2 of my cookies away. I now have 3 cookies left. And then the 6 minus 1 is 5. Okay. Solution number 2, I'm going to use a number line. I am going to start at 65, and we're going to go back 12. So my subtraction is 12. So let's see. I'm going to maybe confuse you. Hopefully not. You can do this a couple of different ways. The first way that makes sense in my head is to go back 10, because 65 is a pretty neat number. I'm going to go back 10. 65 minus 10 is 55. I can count by tens, right? Is 55. So I've gone back 10. How many do I need to go back total? 2. So 55 minus 2 is what? 53, right? So this would be my answer. I want to show you another way. So say I start at I'm still starting at 65, but I always tell you that this number is easier when it's a 10. So let's say I did that first. Let's say I went back 5 to get 65 to be a 60. That's fine, I can do that. Okay? So now I've already gone back 5. How many more do I have to go back now? Well, I can go back another 5. So that way I'm at 10 now. So 65 minus 5 is 55. I've gone back a total of 10. I need to go back 12. So now I can go back 2. 55 minus 2 is 53. Okay. You don't have to do the number line hops the same way that I do. What makes sense in my head may not make sense in your head. So you may like or understand the number line, but your brain might think of different numbers, and that's completely okay. I am just showing you that these are 2 ways that I can think of, but you might have a different way as long as you end up on 53. Okay? For your solution, we have 53 um